Hey, Dr. Power on Class of 1050. This is my submission for the creative assignment due on November 17th. It's called Water for a Cause, and I'll talk more about the name at the end of the slideshow. Let's get started. All right, this is my slideshow. It's called Ma Sabil, which translates to Water for a Cause. Let's go through it. This map looks great. I did not draw this map, but I hope they will give me some credit for finding such a great map, royalty-free. So the region shown here in this map is where we observe the start of human civilization. Specifically, you see at the bottom right, you have the Persian Gulf, and then you see a river that leads into the Persian Gulf, and then that converges into two rivers. If you follow those two rivers up, the area between those two rivers, you see the words Mesopotamia written there. That area specifically is where we observe the start of human civilization, where we started seeing people living all together in cities. You saw government, you saw writing, and a lot of things that we would attribute to modern human civilization. One image that pops to mind about the ancient traditions of this region is pottery. Clay was widely available and had practical applications for the ancient peoples of the time. So more about clay and pottery. Clay was available in Mesopotamia at the beds of the two rivers that form the lifeblood of the region. In Arabic, they're called Al-Dijla wal Furat, and in English, they're called the Tigris and the Euphrates. And they're the two rivers that I was talking about in the last slide, the ones that between them we find the area of Mesopotamia. And those two rivers converged into one later on and went into the Persian Gulf. When clay from those two rivers is damp, it can be shaped into bowls, pots, or flasks. This is often traditionally done with pot wheels, ones that work mechanically. The clay is easily manipulable when wet because the minerals inside increase in volume and become bloated when in contact with water. They are no longer sealed together like rocks, but are rather sticking to each other, and it's a firm stickiness, a stickiness that makes the clay very, very convenient to shape into different objects and work with. When that clay is heated in a kiln or heated with a fire, the water inside evaporates. The clay then becomes hardened with many free spaces inside. Uh, the concept of free spaces inside the clay becomes very important later on in the slideshow. Aside from the obvious practical purposes such as storage, clay also has many decorative purposes. In fact, back then, clay pots were used as offerings or as gifts. With this easily manipulable clay, we saw one of the first instances of beautiful and sophisticated art that still survives to this day. So I think everything I've talked about so far is pretty cool, but we're here to learn chemistry. And one surprising application of this ancient technology is actually for keeping water cool during scaldingly hot temperatures. Thus, a clear connection to the principles of thermochemistry can be made. Let's start with the foundation concept. As mentioned before, the clay is easily manipulable when wet thanks to the absorption of water and the resultant firm stickiness of the clay. It is also easily accessible in the region. When wet clay absorbs a large amount of heat, say in a kiln, it loses the water in the form of vapor and is left rock solid, with many free spaces inside. We note here that the vaporization of water occurred because heat was absorbed, and vaporization is an endothermic reaction. Now we end up with a container with many cracks and crevices in it. Unlike other materials like metal, the hardened clay walls themselves can absorb liquid. Thus, the hardened clay container will become damp on the outside when filled with water. In fact, if you were to put your hand on the walls on the outside of that pot pictured on the right, you would feel the dampness of it. Versus if the pot had no water inside of it, it would just feel like you're touching rock or a really rough surface. All right, so pots are cool. How do they keep the water cool as well? So I want you to look at the diagram that I have here on the slide. Although the walls of the pot are damp, the water inside is actually quite isolated from the heat. This is thanks to the thickness of the walls as well as the rock solid lid. Also, the pot is usually put in the shade if the intention is to keep it cool, as that will dramatically lower the amount of energy going into the water. To go into a tangent about that, try going in and out of the shade on a hot summer day. You will notice that the direct exposure to sunlight leads to absorption of more energy. However, what I explained so far seems to just be the description of a primitive calorimeter. Okay, I could put water inside this pot, seal it, put it in the shade, and the water inside will stay the same temperature. but you'd be surprised to learn that the water will actually be actively cooled. And how does that happen? Well, water naturally evaporates, whether in the pot's walls, or under sunshine. When vapor appears, it will draw in some energy from its surroundings, and if the vapor appears or forms inside of the pot, it will draw in energy from the water because there is no energy or not much energy coming in from the sun. So then the water inside the pot will become cooler, and that vapor will actually be able to escape through the pot's walls, and energy will come out of the system. There will never be a pressure buildup inside of the pot as long as the vapor is forming gradually. Moreover, you may notice that I added in the symbols for wind here. As the wind hits the damp walls of the pot, it will influence those water droplets on the walls to vaporize as well. The water droplets on the walls will also draw in some energy from the water inside the pot, uh, therefore leading to more cooling. So now we have a system that will cool the water inside of the pot, and that's pretty cool. And to kind of summarize that again, the ideal conditions for water inside of the pot to be cooled is if the pot is sealed, if the pot is in the shade, and if the pot is exposed to wind. In that way, the water inside the pot will be cooler than when you first put it in. It's almost similar to sweating in a way. All right, so why doesn't the water temperature go down to zero? If the water inside of the pot is being actively cooled on a hot summer day, if you leave the pot outside with water on a hot summer day and then come back after a while, should you expect to see ice? And the answer is actually no. Uh, if you observe the heat of vaporization of water at different temperatures, you'll see why. You might notice that as we increase in temperature, the amount of energy that it takes to vaporize water decreases. And inversely, if we decrease in temperature, the amount of energy that it takes to vaporize water increases. As the water in the pot gets colder and colder, less and less water molecules are going to have enough energy to reach the threshold they need to vaporize. Thus, we're going to get to a temperature at which the amount of energy being lost due to water vapor is actually going to reach an equilibrium. It's going to equal the amount of energy going into the pot from the sun. And that's actually the stabilizing temperature. And we note that water actually always stabilizes at a temperature depending on how and where it's contained. Our goal here with this primitive pot was just to get that stabilizing temperature lower than the temperature of the outside, such that the pot water is going to be colder than when we first put it in. Okay, so now that we're done with the chemistry part of this creative assignment, I would like to talk about the cultural significance of these pots with water. The water is called mat sabil, or water for a cause. And why is that? So, the culture and religion in Iraq and surrounding countries encourage hospitality, especially to the stranger. To earn good deeds, people put water in front of their houses just for others to come by and drink, especially during the hot days of the summer months. While nowadays you often see fridges or cold water dispensers free for anybody to come by and use, you may once get lucky and notice a clay pot of water outside someone's house. All right, that was the end of my Chem 1050 creative assignment. Thanks, Dr. Power. Thanks to everyone for watching. Have a good one.